Hey everybody, Wayne here. So I was asked a question recently and wanted to go through and do a test to see how it fits in. And the question was, if you discharge your batteries to about 20%, how long would it take to bring those batteries back up to 100% and be ready to use those again? So a couple of things in the test that I set up. I have two batteries. They're 24 volt, 200 amp hours, 5,120 watt hours each. That's the equivalent in a 12 volt system of having around 9 to 10 Battaborn 100 amp hour batteries. So you get 24 volt at 200 amp hours or 400 amp hours total. That would be 12 volts at 800 amp hours. And then I have a little over 10,200 watt hours of total capacity. My units were already running at about 72%, I think it was, some testing that I had done the day before, and I'd been slowly letting the solar charge come back in, but it has been cloudy, so it was a slow trickle charge bringing it back. So I decided to pull the batteries down as close as I could to around 20%, test it with a very high load, see how far I could get down, turn everything off, plug into shore power, and then test again. So if you look at the graph below, you can see somewhere around 8:30, 8:40 in the morning, I added the load of the air conditioner, which is a little over 1,050 to 1,150 watts, depending on the compressor running at other instances. Added in the refrigerator, the fan on high, and the three inside lights. Those combined were running around 1,350 watts consistently. And so over about a 4-hour period, I let those run. So again, the batteries were already down to about 70, 72%. Ran for another 4.5 hours. And the battery started getting, on the Victron inverter, low voltage alarms. So I shut everything off at that point. So we ended up, according to the BMV, at about 24%. Although I think my BMV needed to be resynchronized back with the batteries, which I did later on. So what ended up happening once I started the recharge back? So I turned everything off, turned off the refrigerator, the fan, the lights, and the air conditioner, plugged back into shore power, and I go into the advanced tab and the Victron VRM, and then we'll go down to the VE bus state. So you can see when it was inverting during this time frame for a couple of hours, as it was just providing power back into the unit. And this is a little bit longer than the 4.5 hours because I had it unplugged from shore power before that, just letting the solar charge. But you can see as I come back into the bulk charging that around 12:40, I plugged in the shore power. It started from the inverter bulk charging, and that went until 20:42. So it's about 8 hours in bulk. And then in absorption, it came in and ran for another 2 hours, roughly. So a total of about 10 hours between the two different systems of bulk and absorption, coming back in and charging the two batteries before it went into float at 22:41. This was everything turned off, nothing coming back in, and it was interesting to watch and to see. I don't have a good graph to show it, but shore power started off with only about 11 or 1,200 watts charging the batteries, and it slowly ramped up to around 1,600 watts as you got closer toward the end of this 8 hours for the bulk absorption. So the inverter was watching the batteries and slowly adding what it saw from a voltage standpoint and amperage back in, and noticed that it was sending in from shore power around 13 amps at that point. So hopefully this helps answer the question. 8 hours in bulk, another 2 hours in absorption before it went into float, to fully charge from around 24% back up to 100% on the batteries after I had taken it down to low voltage on the system. Hope this helps. Click subscribe and like, and please let me know if you have any questions. Have a great day.